Not that I worry that much about you guys saying anything, really, but okay. So if we look at page 240, want to look there with me? So we're going to identify and use corresponding parts of triangles, and we're going to use the third angle theorem a little bit. Third angle theorem. You guys remember that one? That ring a bell? Okay, maybe that's a new one. We'll see today. So, right there in the first paragraph, recall that two geometric figures are congruent if and only if a rigid motion or composition of rigid motions maps one of the figures onto the other. So there were different type of rigid motions. Do you remember the three? Translation, rotation, reflection. Dilation? No. Okay. So a composition means just more than one of those things, right? So if we can take a figure like triangle ABC there, and we can rotate it and flip it and slide it some way to get it to map over the top of the other one and fit perfectly on it, then they are congruent triangles. And we need to talk about corresponding parts there. Do you see that highlighted in yellow? Corresponding parts. So let me draw these two triangles, and I'm going to show you a little trick here that should help you quite a bit, I hope. So we have the two triangles. Sometimes when you look at figures, it's hard to tell which parts correspond. Okay? So we've got this one here, A, B, C, and then we got this one, D, E, F. And it's easy enough when we look at them to kind of know, like, do you guys think that angle A and angle D correspond? Yeah, you can tell which ones those are, right? But B and C and E and F, they're a little bit more difficult to tell which one's which. You don't know if this triangle is reflected somehow. Now, if it's just rotated over here, then we know, well, B corresponds to F, right? We know what's going on. But just looking at the picture, it's hard to tell. And it's also hard to tell, which one's longer. Is C, A, and D, F, are they the long ones, or is it isosceles, or are they just really close to the same length? So it can be really difficult to look at figures sometimes and tell which angles correspond. You getting what I'm talking about here? Correspond with one another, and which sides correspond. But if you have a statement about them that says something like this: triangle ABC is congruent to triangle DEF, you don't need the picture to know what's going on, because you can look at this statement right here, and guess what? Angle A corresponds to, yeah, there you go. And angle C corresponds to angle, and angle B corresponds to angle E. It tells you by the order that they're listed which angles correspond to which one, so you know what's going on. And not only that, but segment AB in this triangle corresponds to segment what? DE. Okay? And segment BC corresponds to EF, and segment AC and DF. So as we look at the triangle, find AC. See it? Everyone see AC? And which one does it correspond to? DF. It corresponds to DF right there. Okay? So this congruent statement tells you a lot about what's going on. And remember, we're looking at congruent figures, not just triangles. We're going to be looking at quadrilaterals and pentagons and hexagons, figures with many sides. Okay? So we can't just always just eyeball it and know what's going on. We need to be able to read a congruent statement and write one correctly. Most of the time, we write them in alphabetical order. We just list them in alphabetical order, and you label them that way too. And sometimes you're not sure which direction to go. So it might say quadrilateral MNOP, and you'll see draw some quadrilateral. Okay, do I start here and go clockwise MNOP? Do I start here and go counterclockwise MNOP? What do I do? And the answer is yes. You can start at any vertice and go clockwise or counterclockwise, and the labeling would come out correct. So if I want to start here, MNOP, notice we have segment MN, and we have segment NO, and we have segment OP, and we have segment MP. Got them all. And they're all in order, they all fit. It'll work out. Okay, let's look over to example 2 for a minute. There are two quadrilaterals there, and it says that DEFG is congruent to SPQR. Now, it doesn't say quadrilateral, it doesn't have the word there, but I'm going to say quadrilateral, DEFG is congruent. What do we mean they're congruent? Exact same size and shape. So what does that mean about angle D in comparison to angle S? Their measures are literally equal, aren't they? What does that tell you about segment EF in comparison to segment PQ? Okay, so again, when you look at these two in the picture, it's a little bit hard to tell, well, I guess angle Q and angle F are pretty obvious, aren't they? We can tell from the picture that those two. Right, Ashlyn? Well, good, okay. But what about angle R? What does it correspond to? Look at the picture. What does angle R correspond to? Are you sure?
Yeah.
Look at the congruent statement. Does angle R and angle G, do they correspond? Absolutely. There's no question when we look at the corresponding, the congruent statement, right? So make sure you think about that. So let's see. Do you think that we can make some equations here to help us find some missing values? What do you guys think about segment that's labeled 2x subtract 4? It's equal to 12. Okay. What do you think about the angle that's measured 6y plus x? 68 degrees? Now, you're going to run into this a lot, and this equation, you liking it? Not really. Why not? Right. This equation? Oh yeah, we're good with this one, right? 2x, let's see, equals 16, x equals 8. Okay, now you see what's going to happen now? Right here. Put an 8 there. So 6y, let's see, now we can subtract 8 from both sides, and y equals 10. You okay with this? Okay, I figured it's pretty easy. Showing that figures are congruent. How can we know for sure that two figures are congruent? So, see the girl painting the wall? Not the actual picture of the girl painting the wall, but the cartoon picture of them painting the wall. So there's like mine's orange and blue. Is that what yours are? Orange and blue. So we've got these two. What shapes are those? Okay, quadrilaterals. Good. And we want to know if those two quadrilaterals are in fact congruent. So we've got this wall, and it looks like they painted it kind of like this. They've split it that way. A, J, B, C, K right here. This is D, and that's a right angle, that's a right angle, that's a right angle, that's a right angle, and then they've been nice and numbered some angles for us. Now, not only that, but they've given us some other information here. These two are marked congruent, aren't they? Didn't they use a red? Yeah, these two are marked congruent. These have 3 little marks on them, so they're congruent, they're telling us. These two are congruent. Now, how do we know if the two figures are congruent, though? Don't all of their corresponding sides and all of their corresponding angles have to add up to 180? Okay. Well, does that happen here? Like, let's talk about angles first. What about angle 2 and angle 3? How do you know? Okay, but if they're alternate interior angles, they're only congruent if these two lines are parallel. Are they? Is the line along the baseboard and the line up at the ceiling, are they going to be parallel? Okay, so we kind of know it intuitively, like, well, in most houses that's the way it is, right? Although I have seen houses where it's not that way. But take a look at this. See AB and DC? They're both perpendicular to AD. If they're both perpendicular to AD, they're parallel, aren't they? Okay, yeah, they're parallel.
Teachers, we need to excuse the student council members. They need to go to Mr. White's now to get ready for the group beer float party.
So yeah, these two are on a transversal through parallel lines that are alternate interior angles. What about angle 1 and angle 4? Yeah, there you go again. Okay, and then, I mean, what about JK? It's in, so in this figure here, we've got JK, and then this figure here, do we know that JK, is it congruent?
Yeah.
How do you know? Because it's the same segment in both figures? So is every segment congruent to itself? So you guys are all saying that JK is congruent to JK? Wouldn't life be a little tougher if that weren't true? Yeah, that's got to be true, right? That's got to be true. So we've shown that every single side, every corresponding side is congruent, and every corresponding angle is congruent. So are these two quadrilaterals congruent figures? Okay, so that's what the process we've got to go through. Down at the bottom, properties of triangle congruence: reflexive, symmetric, transitive. For any triangle, the triangle is congruent to itself. What say you guys? In any triangle, is a triangle congruent to itself? What is that? Oh, okay.
Yeah.
What do you think? You guys don't seem sure about this. Let's start with a triangle. We'll just call it ABC. Is triangle ABC congruent to itself?
Yes.
Okay. What about symmetric property? If triangle ABC is congruent to triangle DEF, is triangle DEF congruent to triangle ABC?
Yeah.
Yeah. Okay. And then the transitive property. So this is nice because you don't have to break it down into individual little parts. You don't have to talk about their segments all being, transitive property that way and all the angles. You can just say, look, triangle A is congruent to triangle B, triangle B is congruent to triangle C, Triangle A is congruent to triangle C. Transitive property of triangle congruence. Okay? That'll save you guys a lot of time. All right, third angle theorem. Let's see if I can prove this to you. I've got these two triangles, A, B, C, and D, E, F, surprise, okay? And we are given that angle A is congruent to angle D, and that angle B is congruent to angle E. Is angle C congruent to angle F? How do you know? Okay. These three angles, what do they add up to? These three angles, what do they add up to? And how do you know? What's that theorem?
Triangle sum theorem.
Triangle sum theorem, okay. So, triangle sum theorem says the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180. And it also says, in the other triangle, the measure of angle D plus the measure of angle E plus the measure of angle F, equals 180. They both equal 180, so do they equal each other? They do. And we know A and D are congruent, so we can subtract them from both sides, subtraction property. We know B and E are congruent, subtraction property. And what do we have? Third angle theorem. It's almost not even a theorem, isn't it? Is it barely a theorem, or do you guys all look at it and go, yeah, that's got to be right? What'd you say? It's almost a postulate. Yep, almost a postulate. In fact, most of the theorems we've done up to this point have almost been postulates. Okay, so example 5. Let's follow through this one now for a second. Proving that two triangles are congruent, and this is going to be one of our main goals in this chapter, is proving triangles and other figures are congruent, mostly triangles. So you have to be able to show that every side is congruent, every corresponding side, and every corresponding angle is congruent. So let's take a look at example 5 for a minute and look at what we're given. See the picture? Everyone study the picture for a second while I write the congruent statement. You are given triangle ACD and triangle CAB. And we're supposed to prove that those two are congruent. So look at the picture for a minute. What two angles do you know are congruent in the two? Okay. And then there's another angle there going on, isn't there? So there's one with a double mark, one with a single mark. So what about angle D and angle B? Third angle theorem, right? So you're given two angles of the two triangles are congruent. Third angle theorem says the third angles are congruent. Do we know all three corresponding angles are congruent? Okay, we're good there. What about the sides? It looks like in the side, it looks like DA, that's from D to A, and from C to B, they're congruent. And then DC, this one, and AB, this one are marked congruent. What about AC? Notice that we have AC. See, AC? We have that in both triangles, don't we? Is AC congruent to itself? Yeah, every triangle's or every segment's congruent to itself, right? Okay, so are all three angles and all three sides of these two triangles congruent? Well, all the corresponding parts then, right? Are the two triangles therefore congruent? Yes. Wouldn't it be nice if we didn't have to go through all 6 pieces Wouldn't it be nice if there was some way maybe that we could know without having to go? Well, we'll see about that later, but let's look down at the bottom of page 242. See the figure on the left? Find the measure of angle DCN. What is it? 75? How do you know? I mean, just because two triangles come together, does that mean that they're congruent and that all their corresponding parts are congruent? And does it tell you that those two triangles are congruent? No, but are they? Are you sure? What do we got here? We got this, comes over like that, comes down, got that thing going on. This is a triangle DCN, and then triangle SRN. And these two are marked congruent. These two angles are marked congruent. So we got one angle and one side. I can see another pair of angles though that are congruent. Can you guys? Which ones are they? Which two? I'm not hearing the word that I'm thinking of. I see you guys doing this thing. Which two are they? What's the relationship? Oh, that's the word I was looking for. The vertical angles. The vertical angles are always congruent, right? Well, now we've got two angles and the two triangles congruent. What about the third angles? Okay. Now they look like right angles, but we don't really know if that's true or not, so I'm not going to mark them as right angles. Okay, so the three angles, so the triangles are at least similar, but are they congruent? They have to be. They have to be. I mean, do they have to be? But I mean, how do you know that like DC and RS are the same length?
Because B and S have to be at that specific angle toward each other.
Yeah, but I mean, are the two triangles, in order to prove they're congruent, don't all three angles and all three sides, all the corresponding parts have to be congruent, right? Say it louder. Oh, you know, you would think so. But I can definitely draw a figure like that, where all three angles are going to have the same measure, and these two are parallel. You know. Oh, but then those two wouldn't be. Okay, so. So you're looking at it, and I think you're all like, okay, it has to be that way. They've got to be the same size and shape, right? But I don't think you're able to actually prove that right now. But you will be. You will be able to. For right now, though, you've got to have something where you can definitively say that all three sides are congruent. All three corresponding sides are congruent. So notice question number 5. What's the question? What additional information? We need to know that DC is congruent to RS or SR?
or SR.
SR. And we need to know that DN is congruent to
And SN.
SN. That's the additional information we need. We, and I'm gonna leave me out of this. You do not know that those two triangles are congruent. You think they are, and you might be right, but you can't prove it yet. You can't really say yet. In order for you guys to say two triangles are congruent, you have to be able to show all three corresponding sides are congruent and all three corresponding angles are congruent. That's it. Okay? So that's what you got to keep in mind as you do this exercise. There you go.